Okay, so now we're going to move on to the example below the table where it says, example 1, use graph A at right to determine the number of solutions in each system. If it has one solution, then tell what the solution is. So in this case, obviously they've already done the graphing for you. You just have to find the two lines and then use the table that we just made to figure out how many solutions it has. So if I look at example A here, it says y equals negative x plus 2. So I look over here for y equals negative x plus 2, and I can see that this is this blue line here. Now I highlighted these lines just to make it a little easier for this demonstration. If you want to highlight your lines, you can certainly highlight your lines, but you don't have to. So anyway, so y equals negative x plus 2 is this blue line. And then the second equation is y equals x plus 1. So I see that y equals x plus 1 is the yellow line. So I follow the two lines. When I follow the blue and the yellow line, I see that they do in fact intersect. And since they are intersecting lines, then that means that they have one solution. So I go ahead and I write one solution. And then the next step, since it does have one solution, then anytime it has one solution, you have to write the coordinate point of what that solution is. So I look for where they intersect. And this is kind of a difficult example. It's not usually this difficult. Normally they are whole numbers or integers, no fractions or decimals. But in this case, I can see that they meet in the middle here. So that means that I would have to go over about a half and then up 1.5. So in this case, we would write the solution as 1/2 and 1.5. Okay, so part B then is the same idea. You're just following the two lines to see how many solutions. So y equals negative x plus 2 is the blue line again. And then this time the second one is 3x plus 3y equals negative 3. So I see 3x plus 3y equals negative 3 is this green line. And then since we're comparing the blue line with the green line, you can see that those are parallel lines. So since they are parallel, then they don't intersect, and that's why they have no solution. So at that point then, all you need to do is write no solution. And then the last one starts with 3x plus 3y equals negative 3, which is the green line, and then y equals negative x minus 1. Which is up here, it is also the green line. So that means that this is an example where we have the exact same lines. And since they are the exact same lines, then that means that it has infinitely many solutions. So you write infinitely many solutions, and that is it for that example. So now, right underneath that, there's another example. This one is for you to do on your own. So I'm going to ask that you pause the video, try A, B, and C on your own, and then press play again when you're ready to check your answers. Okay? Okay, so hopefully that wasn't too difficult. For the first part, A, when you followed the two lines, y equals negative x minus 3, that should have been what I have now highlighted as the pink line. And then 2x plus 2y equals negative 6 also turns out to be that pink line. So since they are from the same line, then that means that they have infinitely many solutions. And then again with the next one, this one starts with y equals x minus 1, which is the yellow line. And then 3x plus y equals 3 is the green line. This time you can see that these two lines intersect right here at this point. So that means that they have one solution. And then don't forget, when it has one solution, then you have to state what that solution is, just like we did up here for part A. So this time it meets at a nice point. That point is just 1, 0. And then the last one, 2x plus 2y equals negative 6 is back to that pink line. And then y equals x minus 1 is this yellow line. So since these lines also intersect, then again, these have one solution, and then the point is negative 1, negative 2. Okay, so now we're ready to move on to the last part at the bottom of your page.